Hello everyone. I have been receiving requests for me to share the solutions for question 7 for Pure Math 1 9709 slash 13, that paper 1 variant 3, May June 2025. Right, so let's just go through the question and then we'll share the solution. So question 7, a curve is such that dy dx is equal to 3x squared plus 10x minus 8. Part A, find a set of values of x for which y decreases as x increases. All right, so here what you are given for this curve is not the equation of the curve itself, but the gradient function of the curve. And so when we talk about the relationship between increasing and decreasing y and x, right? If the behavior of y and the behavior of x are in opposite directions, that means here y decreases as x increases, right? When this happens, that means the gradient of the curve will be negative, okay? So as long as they are opposite behavior. So for example, if it's y increases as x decreases, right? That also means that the gradient of the curve will be negative. Okay, so here in this case, for this question, y decreases as x increases. Okay, so since they behave in reverse directions of each other, right? They behave in opposite directions. That means the gradient dy dx, right, will be negative for this curve. Okay, so since the gradient will be negative, then we just set this polynomial, this dy dx, to be less than 0. So now what we get here is a very simple quadratic inequality. So just to find the uh, solution to a quadratic inequality, all you have to do is uh, pretend that you're solving a quadratic equation. Okay, for in this case we factorize, and we still set it to be less than 0, right? And now, in order to actually find the solution for this inequality, the best way is to visualize it. So the way to visualize, we check first. This is a positive quadratic, right? 3 here is positive. The leading coefficient of your quadratic is positive. Therefore, you'll get a smiling curve, right? Next, you can see here that there will be two critical values. So that means there will be two intersections, right? And one of them is negative 4, right, from here, and the other one is positive 2 over 3. Okay, now we look at this quadratic, and what we want is for this quadratic to be less than 0. Okay, so less than 0 means we want it to be, we want the part of the quadratic curve that is below the x-axis, and the part of the quadratic curve that is below the x-axis is this part. So what values of x, right, gives you this part of the curve? That will be the values of x that are in between negative 4 and 2 over 3. So that means our solution, the set of values of x for which y decreases as x increases, is x in between negative 4 and 2 over 3. Very simple, right? This part here, 3 marks, very simple. Just set this inequality, solve the inequality, and get your values of x, right? That will be all the 3 marks. All right, let's go ahead and go to part B. All right, so part B, it is given that the maximum point of the curve has y coordinate 27. Find the equation of the curve. All right, so we were given the gradient function. And if you have the gradient function of the curve, to find the equation of the curve, all you have to do is to integrate this curve, right? So to integrate the gradient function. So if, sorry, not integrate the curve, integrate the gradient function. So let's integrate the gradient function. When you integrate the gradient function, we have y. So the integration of this dx, this is a polynomial, this is a quadratic, very easy to integrate. Just apply the rule, and you'll get y equals x cubed plus 5x squared minus 8x plus c. This is the unknown constant. So in order for us to actually find the value of c, we need some information. In this case, this question has given us the information. That is, the maximum point of the curve has y coordinate 27. So that means that we need a value of x and a value of y to substitute in here so that we can get a c. So this information helps us to do that. So what we have to do is look at this equation. We can see it's a cubic equation. So we have our cubic equation. That means our cubic curve will look something like this. Okay, and we already know dy dx is negative between negative 4 and 2 or 3. The gradient here is negative, right? The gradient is negative between negative 4 and 2 or 3. Okay, so we can label as such, right? And then we can figure out, hey, which one has the maximum point? In this case, we can see very clearly that the maximum point happens when x equals negative 4. That means, right, one of the points on this curve is negative 4, 27. That means we can substitute 27 into y and negative 4 into x, right? And we go ahead and do that, right? And from here, very simple, just find the value of c, make c the subject, right? And you get c equals negative 21. Now, the danger here sometimes for some students, they stop here, right? Usually they like to have the solution to be a letter equals a number. In this case, they are not asking for the value of c, they're asking for the equation of the curve. So make sure you don't forget to, in the end, write down the equation of the curve and substitute the value of c that you have found. So final answer, y is equal to x cubed plus 5x squared minus 8x minus 21. So this is our equation of the curve. And if you did get this answer, then you have done a good job.